Okay.
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 It's time.
Let's start part two.
Yeah, we said 2, it's already 2:15.
Yeah, and let's get going again. We're well aware of that it's Friday today, but this is much more fun than an ordinary Friday. So hang around because we have still really interesting stuff on the list. As usual, the coffee is still down there, so if you want coffee, just go for it, okay? And we have a lot of things for the afternoon session.
And we start with a very interesting one with Francesca that is going to present on microplastic under project.
Super, let's get going.
Okay, hi everybody. The presentation. Okay, I'm going to tell you about this project, Microplastic Hunter project, and of course it deals with plastics. And everybody knows, I mean, in 2020, in Nature, they published a paper that said that in 2020, the anthropogenic mass surpassed the global natural biomass, the living biomass. And in particular, if we consider plastic, in 2020 we had on the Earth 8 gigatons of plastic, respect 4 gigatons of animals. So the problem is great. Most of the plastic that is produced for packaging, about 40% of the plastics. So for products that follow this approach, take, make, waste. If we consider the yearly production of plastic, so about 4,000 million tons of plastic every year, about 3% of this plastic leakage into the sea. And this is why even the UN inserted the plastic as one of the 3 that has to be solved to reach in this case, the goal 14 of the 2030 sustainable agenda. And it is projected that the plastic that will enter the sea will be double or triple in 2040. The macroplastic is not only the problem. Another problem is for sure microplastics, so all the plastics that are less than 5 millimeters in length. These plastics comes directly from microplastics produced in this tiny dimension, or even come from the degradation of the macroplastics in the sea. There are still a lot of questions open about the macro, micro, and nanoplastics. And one question deals with how much plastics is on the environment. Because in order to solve this problem, we need to know the baseline level of contamination of the microplastics in the environment. I work at CNR, and we do a lot of research in this field, thanks to different European and national projects. And every year we go around the sea, even outside the Mediterranean Sea, to do sampling campaign to understand how much plastic we have in the sea. We are now publishing different papers. We identify some hotspot area in the Mediterranean Sea. And we roughly know how much plastic and microplastic we have in our Mediterranean Sea. But this is not enough to know exactly the level of contamination and the area where it is necessary to put in place some specific remediation action. So our data are included in what the UN agenda consider as traditional data, but there are a lot of non-traditional data sources that can be used to assess the status of implementation of the SDG goals, of the goals of the agenda. And among these new non-traditional data, citizens science-generated data are considered as a good source of data to understand the level of contamination. There are a lot of citizen science projects that deals with the macroplastics, and I think that the most famous project is the Marine Litter Watch that has been launched by the European community a few years ago. And thanks to this project, the single-use plastic directive has been developed based on the 10 most common plastic objects that have been found thanks to this citizen science project. There is less citizen science project dealing with the microplastics. And so we asked to a specific group of citizens to help us in spread the knowledge of the contamination in our sea. And we choose a specific group of citizens and sportsmen like kayakers. And so the project, the Microplastic Hunters, come from this idea to put together sea kayakers together with a very cool crew. You see some of the partners, Outdoor Portofino, the Italian Naval League, the Coast Guard, Mare Vivo, that is an Italian ONG, and the CNR, supported by different other partners. Microplastic Hunter project was born 3 years ago, about, and have been also inserted in a project funded by the Genova City Municipality that finished last year. In order to use citizen science data, it is fundamental that the data are robust and that they are validated. Otherwise, it is very difficult to use this data for scientific evaluation. So the first things that we did in the microplastics project was to standardize the method and to verify the data quality of the data that we collected with our methods. And to do the validation, we did a different sampling campaign, comparing the new methods with the traditional sampling method used, for instance, in the MSFD guideline for collecting microplastics. I'm going to show you a video that explains the project. This is one of the campaigns that we did for validating the methods. These are our kayakers from Outdoor Portofino. And to collect the sample, we built a little version of the manta net that can be trolled by the kayakers. That is the manta, this one. And this is the traditional manta net used for the scientific sampling. Manta net, the little manta, the mini manta net is very light. To clean the mini manta net, and at the end of this sampling, the kayakers just take out the filter from the bottle at the end of the mini manta net, they put in an envelope, and then they give the sample to us for the analysis. So the comparison has been performed comparing the two boats used and, of course, the two manta nets used for the sampling. The results in this graph, you can see the abundance of microplastics collected with the mini manta net compared to the huge manta. And we saw that the efficiency of the collection with mini manta is even higher than what we collected with the traditional sampling methods. If we compare the accuracy of the two instruments, and this is the comparison of the size, class, dimension of the microplastics collected, the accuracy is the same. So we found the same size distribution with the two devices. And the same accuracy has been found even comparing the polymer collected using the two devices. The mini manta net collect a little more polypropylene than the manta net, maybe because it is it works in less deeper water, and so the polypropylene is lighter than the polyethylene, and so maybe this is the reason of the difference. But anyway, the accuracy is very good, even concerning the polymeric composition of the sample. So we can say the mini manta has been certified, so we can consider this method, and the citizen science help very useful in having good scientific data. And this demonstrates that if adequately trained and if the citizen scientist is asked to perform a well-defined task, they can support in a very effective way the scientific investigation. Indicated that we think that the Microplastic Hunter is a successful citizen science project because it put together different stakeholders, and this is one of the bases of a good scientific citizen science project. In fact, we had the public, of course, the citizen scientists that Outdoor Portofino gave us, the experienced volunteer coordinators such as the Coast Guard, the dedicated non-profit organizations such as Mare Vivo and the Italian Naval League, of course, local government, in this case were the Genova municipality that support our work, and the professional scientists like we at CNR. So what next? We hope to spread this method because in this picture, these are the 12-point spot where the regional agencies for the environment in Liguria sampled the water for microplastic analysis for the Marine Strategy Framework Directive. And you can see how many spots we could have involving the Italian Naval League location or the Kayaker Club location. So we could spread the investigation of the sea. And we hope to involve more and more partners in this project. So just to finish, we think that this project improves the quality of research, making it more relevant for the society and providing to us good scientific data, and it succeeds in breaking down, in what is one of the main aims of the citizen science, that is breaking down the barriers between the science and the people, especially in this period that after the pandemic period, we are living a sort of post-truth era. Everything is true, and the scientist has no more power in defending our position. So, and also it is very useful because the mobilization of a huge number of people increase the number of scientific data and increase the strength of our knowledge. So, thank you, and thanks to all the partners that support us in this section.
Thank you, Francesca. I mean, this is a brilliant example of how you can put in place, a concrete action in order to, implement citizen science. One question I have is, while the manta is, we can understand it's really cheap, which is the work that you need to do? How much time do you take really to get out data from what you collect with manta? Because that is also cost effective. There is an effort.
Yeah, the time for the analysis, it's quite time-consuming, but we think that the cost-effectiveness of the investigation, it is anyway good for the scientific side, because if you think how much does it cost to perform a scientific sampling campaign with a boat, with all the crew, with all the expenses for the management of all the stuff. Now, what we are trying to do is to find someone that can build the mini manta in a cheap way, because we build the manta by ourselves. Myself, and the wife of my colleagues, we just cut and build the manta. And we asked to a producer of a classical manta net, and they say us that they could sell this little manta for 1,500 euros. It's too much.
It's too much.
So we have to find someone, some little company that is able to build it in a cheapest ways. Otherwise, I will change my job and I can build manta.
And another question I have is, how do you manage the supply chain towards to you? So how do you plan the activities? How you collect the sample from the field? I mean, when the citizen scientists have collected, how do they ship the
In
thing?
this case, the shipment is quite direct because we always work here in Liguria with the support of Outdoor Portofino, and so it's a direct connection. Our idea is to expand this project to involve different kayaker or sailor team along the Italian coast, and to find some research center close to this spot able to catch the sample and to do the analysis. So we cannot think to do all the analysis by ourselves because it would be a huge amount of work. But if each group of citizen scientists has its reference research center or regional agency center to give the sample, this could make more effective the investigation.
Oh, very good. I mean, again, collaboration is a key
Yeah,
word
yeah.
in this activity. There is any other question from the,
Thank you. I was wondering, so how big is the mini manta compared to the classical manta? And how long do you need to keep them in the water? And up to which speed they can resist without breaking?
Okay. The mini manta is something like that, and the manta net is something like that, the mouth. The length of the net is about, for the big one, 2 meter and a half. The mini manta is 70 centimeter, so it can be cleaned by one person alone. And the speed that can be used with the kayak in a normal, so it's with the boat we have to go less than 2 knots of the velocity, and I mean it never break. It never happened to me that it break. Of course, you cannot go faster, but not for a problem of the manta net resistance, but for a problem that if you go too faster, the water just come out from the nets and it doesn't work. It's like to throw a bag.
Good, thank you very much. So we move to the next presentation that is from Emanuela Del Dottore from IIT. Welcome. Yeah. That is also going back to some of the activities that we also presented yesterday. Yes, under the RISE project. Emanuela, up to you.
Thank you. Good afternoon, everyone. I'm Emanuela Del Dottore from the Italian Institute of Technology, and who was here yesterday have heard about this RISE project that is a regional project funded by the PNRR. IIT is coordinating within this project the work package number 1, whose aim is to develop an ecosystem of robots and AI technologies to support environmental management of the region, Ligurian region. I guess it's going, no? Yeah, okay, I was, sorry. The aim is mostly to develop innovative materials and sensors that can be embedded into various robotic platforms or released by these platforms in a distributed manner, capillary manner, in order to collect distributed and punctual information and data that can be then elaborated with the AI models that will be developed. Specifically, some of the output that we expect, that we envision from this project converge into robotic platforms and devices for monitoring air, water, or land, and in particular to address reforestation, precision agriculture, manipulation, of course, monitoring over these different scenarios. This project basically also embraces the vision that we have in our laboratory. That means to develop future technologies that are more effective, less expensive, and also that can perform effectively and efficiently in a world that is changing. So thinking to scenarios that are highly dynamic and mutable, and that to have technology that can also better integrate with the ecosystem. To this aim, we target research in developing sustainable materials, new green energy solutions, but also the design of both hardware and software that can be less energy consuming. How we do this, we implement the biosphere approach. What does it mean? We look at different biological systems. We have different models that nature can provide us, from which we can extract the basic working principle, and so we can draft the specifications for our devices that can operate in the industry or, for instance, in the exploration and monitoring of the environment. And somehow we also go back to biology through this approach and through the tools that we can develop by better understanding also the living beings. Some examples, for instance, are plants. We get inspired by plants, in particular from the apical region, which are the very extremities, so the apex of roots and shoots, where there is the growth. So plants explore the environment, they move in their environment through addition of new cells at these extremities. And we have imitated these strategies of movement in our robot by implementing a robot that basically can build by its own its body through the miniaturization of the working principle of FDM 3D printers. So here we have an example of this robot that is moving in an ugly unstructured environment. The robot is let to grow by itself without changing, let's say, its control parameters, so constant control parameters, and it can adapt its navigation according to the physical constraint that it can perceive. But also, we can get inspired from other type of structures taken from plants, like microhooks or microstructures that are present in many leaves, for example, of climbing plant, to develop functional surface in order to improve the friction, the anchoring capability of different devices. In this example, we can see a mini car that is able to climb a slope thanks to this functional surface attached to the wheels. But also we can get inspired from plant seed dispersal strategies. In particular, we analyze the morphology of these structures, the materials and the structures, the architecture of their structure to imitate the similar design and develop completely biodegradable devices, artificial device that can biodegrade over time into the environment, while actually we can also functionalize these materials in order to monitor in having multiple of these devices distributed over a large area. We can have a distributed monitoring of the environment. But also we have seen that plants can generate electrical signals that can travel along their vascular tissues upon mechanical stimulations. This means that we can also harvest these sort of spikes and, for example, power small functionalities like LEDs or sensor. We have not only plants in our laboratory as a source of inspiration, but we look also at animals, in particular at soft-bodied animals, thanks to the large deformation that they can undergo. By imitating their strategy of movement and by trying to imitate this large deformation, we can also develop new technology that can move in very cluttered environment. But perhaps the most appealing model from nature in the field of soft robotics is the octopus. It is a very incredible animal. We got inspired from this animal, for instance, to develop artificial suckers by mimicking exactly the internal morphology of this structure to improve the attachment capability of the artificial suction cup in a wet environment. The octopus is an incredible animal. He's completely made of muscular hydrostat, so there is no skeleton inside, but it is able to stiffen locally its body. It can switch from different gait of locomotions to manipulation. He's incredibly intelligent. He has most of its neurons distributed all over its body, so it can demand to the actuation, the response to the stimuli they receive from the environment to the periphery of its body. We also developed, inspired by its tentacles, a soft robotic arm, completely made of soft materials, in order to retrieve different type of object in a confined environment, in confined space, wet condition. It is able to move, in fact, into oil and dirty environment and under pressure. This mechanism, this robot, can retrieve, as I was saying, different type of object, very irregular object, unknown. Let's say the problem was to retrieve unknown object from wells. And so we can imitate some of the movements that the octopus can perform, for instance, the twisting, like in this example, to retrieve cylindrical, semi-cylindrical objects, or to exploit the softness and the compliancy of the body to comply with very strange things, like the springs that you can see in the last pictures, or in fact, also exploit the suction cup to retrieve very small objects, like in this example here, or to improve the grasping force of this system. The aim within the project RAISE is to, in fact, push forward this technology, embed distributed sensing and distributed control, and integrate these arms in autonomous vehicles for marine applications. And for instance, we can exploit this solution to collect biological samples for gentle grasping, or for retrieving garbage, collecting garbage from the surface. Thank you. It's
Thank you.
a rush end.
Thank you, Emanuela. Thank you very much. Is there any question from the floor? Otherwise, we can move to the next one that is going to present on soft robots for ocean exploration. Simona, up to you.
So this works?
1 second. Wait for the presentation. There you are.
There we go. Thank you. Okay, so I am Simona Racri, and today I'm going to talk about innovative marine technology on the rise. In particular, I'm going to focus on the cost-effective technology, novel data, and eco-robotics. I'm also going to touch upon the unexplored ocean, because as we've heard many times today in the past days, the ocean is incredibly important for human life because it's the main source of food, energy, and is also one of the main regulators of our climate. But thank you. So, what we mean when we say that the ocean is mostly unexplored and is more unexplored than the surface of the moon, for example. Well, I think that this image gives us a good idea of what it means for it to be unexplored. So the red patches contain what we know about the ocean the best, which is the red patches are the portions of the ocean that are entirely contained within 2,000 meters. Everywhere else, all the blue patches have something that has to be unveiled. Below 2,000 meters, it is massively undersampled, and there are informations there that we yet have to collect. How do we push this boundary? So the way to go is raising marine technology, new technology. But how has this been done so far? So far, what we do is actually use, among other things, oceanographic vessels. This is a picture of a velella that I took during my first oceanographic campaign in the Western Mediterranean. So we were going across the Mediterranean and performing hydrographic transects, which are one of the few ways that we have to actually measure the entire water column, even going below 2,000 meters depth. So, but we know that now oceanographic ships are extremely expensive. They're expensive economically, they have a human cost, and they also have, they demand a lot of time. In fact, being that expensive, you think that an oceanographic vessel can cost several tens of thousands of euros. It has to operate 24 hours per day, so people have to work continuously on top of that. And on top of that, it also has a not negligible carbon footprint. And what we want to do is understand the ocean, but do not exacerbate its condition and the anthropogenic impact that we have on it. So we have to minimize our carbon footprint, even when we go out there and we measure it. So back to rising technology, new marine technology. So one of the first projects that I've worked on about low-cost marine technology was actually developed was concerning offshore energy platforms. It was developed under the umbrella of the Orca Hub project, and we actually created this robot called the Limpet. It was bio-inspired, and depending on the different encapsulations that we used, it could work underwater, in the splash zone, or in air. But it became clear quite soon that one of the problems that we had to face was actually data treatment. So marine technology that is not commercialized and it's developed in-house often doesn't have a native software to treat the data, and often collects data that are not standardized. So even there, you see at the top part of the screen, we have raw data, and the bottom part is the data that we actually needed. So we had to develop a bespoke algorithm to actually extract the information that we needed. In this case, we were monitoring a wind farm, and we had to check whether the wind farm was working properly. So the peaks correspond to the passage of the blades of the windmill. So this, in contrast, is what we have when we have a commercialized CTD, for example. These are data that have been collected in the Corsica Channel by a profiling buoy that was measuring classical CTD parameters. And you can see that the data is straight away interpretable because we have a native software. And what I like about this picture is that, for example, in the salinity panel, we can already spot the Levantine intermediate water. That for the physical oceanographers here and for those that know the Mediterranean water masses, is actually kind of the polar star in the Western Mediterranean Sea, because it's a particular water that we soon learn to recognize as physical oceanographers in the Med. It is created in the Levantine Basin, and for evaporation processes, actually increases its salinity, and then it sinks and loses loads of oxygen for respiration processes. So you can see it in the red patch at the bottom of the salinity panel. So that's the signature of the top of the Levantine intermediate water. And when you are on an oceanographic ship, as I was doing loads of hours measuring CTD casts, that's one of the first water masses that you actually see and recognize. But back to what we can do to push the boundary of ocean observations using rising marine technology is actually using new materials. So what you see here is a biocomposite that has spent in the water, in fresh water, 19 hours. And we can already see in these images that it starts to degrade after 19 hours. So now what we are doing at the moment is to exploit this knowledge to create transient components of fixed observatories so that we can deploy small fixed observatories and then recover the entire system. And this is something that can be done and will leave behind no footprint whatsoever. So about how do we do that, and what robots can we use to perform this task? So INM is the Institute of Marine Engineering, which is the institute that I belong to, and it is part of the National Research Council of Italy. INM has been creating marine robots for the last 30 years, and what you see in this picture is actually their fleet. In this fleet, the robots, my favorite robots, I know you shouldn't have some, but I have them, and it's Swamp, which is the yellow and black one at the top, and Proteus in the middle. What's special about them, and also about many others in this picture, is that they are modular and they are reconfigurable. So they can operate in different modalities, and depending on the scientific mission that they have to tackle, then we can adjust the payload, the modalities of sampling, the modalities of navigation. Both Swamp and Proteus have been in polar missions. Proteus came back not long ago, and Swamp is actually already on the way, or maybe already there, to the North Pole for a next mission that is going to start in a couple of weeks. So when I joined INM, we realized and we actually started to tackle the challenge that I touched upon before, which is the data challenge. So we realized that to gain full awareness when interpreting data coming from emerging robotic platform, we need to render the coupled data set, and by coupled I mean environmental and robotic data set, fair and publishable and interpretable. So why is it important? Because robotic data give us an awareness of how the robot performed, what happened when we collected the data, and it gives us the possibility to build very precious time series that are so vital in oceanography and to interpret the variability of our ocean. These long time series, and by long I mean decade long, they are actually going through time, but also through platforms. So the more we know about the data, the more we know about the platform that has been collecting it, the more awareness we have when we interpret this data. So how did we bring together all of this? You see there also the bio-inspired robotic arm that IIT Manuela has been talking about just then. So we decided under the umbrella of RAISE, which is the PNRR project that operates in the Ligurian territory, to integrate some of our platforms, not necessarily SWAMP that you see in the picture, but maybe also Proteus, with the IIT arm and also the Guard1. And I think that there is the chance to see one prototype of Guard1 downstairs if you want. So integrating this, we can tackle challenges such as delicate marine sampling. Even environmentally challenging areas can be sampled like that. And we were thinking also about collecting ghost gear and monitoring Posidonia fields. With this, I think I'm done. This is just a picture that I'm sure Antonio will recognize because it is in his book. And it's a very ancient map drawn in 1835 of the possible location of the Northwestern Passage. So if you have questions, I'm very happy to answer. Thank you.
Thank you. Thank you very much. But we have also Giuseppe, who is the real owner of that book. So if you have also a question about that, I mean, history of the oceanography, I mean, we have our Bible there. So if there is any burning question in the floor, we go for it. Otherwise, I would like to move to another topic that is really related to everything that we discussed during the day, because we're speaking about scaffold, we're speaking about tools that are going on the sea, but we need also to be sustainable and I mean, think about also being cost-effective when we design the fleets that we put in the sea. So, Anthony, I want you on the floor and talk about, I mean, this amazing work you're doing.
Okay, it's working? Yes, okay. I'm Anthony, and I'm talking about boat. He's handicapped, and he said, I know the things, but I don't know how they work. Yes, I am an architect. I design a boat. I don't know what the chemist, the environment engineer, what they do when they work. And then that's why I ask them, and I ask what they want to do their job. Okay, what do they have to do? They have to go there, under the coast, in the rivers, in very far in the ocean, to do what? To take sample, to check the water, and send the result. I don't know where, I don't know for what, but I know that they have to do that. How they have to do that? With a boat, not a IMOCA, because the IMOCA is a very difficult boat. It's good for expert sailor. It's good for a strong man. It's not good for chemists, for engineers, for students. They have to stay on the boat for a long time, and they have to work, to stay to the table, to check data, to do that. How I can help them? I help them studying what they need. They need this. They have to do this. They have to take water to put inside, to check that, or something like that. In this situation, the situation is that, sometimes that, or this one. You have seen 5 types of boats. We have more types of boats to do that, but one for the river, one for the ocean, or something like that. We are studying a boat for all over the situation, if it's possible, obviously. And what we checking for that? We need this, a boat for ocean, extreme condition, shallow water, rivers, but we need adequate dimension because we have minimum 10 people on board, because 2 members for the crew and the other one, they are there for work. The best boat at the moment is a multi-hulls. Why? Because we have this situation in the sea, especially outside. And we need to use the sail. Why the sail? Because the sail don't use fuel. It's cheap, and we can travel how long time we want, like the IMOCAs. And the situation is, if I use a multi-hulls, I have more stability. And that's important if I have to stay to the table, to check, to write, to talk, to do many things like that. This is an example. We have made this many years ago just to fish mussels in Adriatic Sea. And this is important because they work on the side of the boat. But they don't want to go in the sea. They want to stay on the boat, especially in winter. And this situation is perfect for them. But there is another problem. If we work with the chemists, they don't want any interference in the water with the sample. And that's why they don't want fiberglass, carbon fiber, or something like that. What is the material for do that? Aluminum. Because we can use aluminum for many other reasons. We can use recycled aluminum, and we can recycle it at the end of the life. Perfect material. And it's cheap. It's cheap to buy, and it's cheap to work. This is an example of the catamaran that we have seen before. And we can use with weld or many other typology of work, very cheap. We don't need a form. The propulsion. This is the big example. On the boat, we have to stay for a long time. These guys on the IMOCA, they don't care about have a good food, have a good sleep, or something. That's a race, just a race. That's an important race because for the world, they show all the world the situation of the sea. But in a professional situation, we need a good boat where you can sleep, you can rest, you can eat in a good way, and you need a lot of space and volume to put the sample. Because some operation you can do immediately, but many other operations they carry out on the board and they carry somewhere. I repeat, I don't know the chemist's job, but I ask them when they want, what they want to do this job. This is the last example. This is 22 meters catamaran, and they can carry 14 people. 14 people at the top. 2 or 4 for like crew, and the other for the other job. And it's important because you have the space for the crew, for sleep, and for cooking. Because it's important when you say you are sailing in a cold place to have a hot food or something like that. This boat can travel everywhere in ice water, hot water, because the aluminum on the bow is very strong. Just to cross, this should crash the ice if you go in Antarctic or something like that. But it's important because it can go in very, very short water, very close on the beach. And you can do the sample in the river or in the lagoon. For example, you can go in Venice because they have 80 centimeters of deep. And it's important, but you can see here the proportion from the long and the large. And the initial stability is very good. And you don't have stomach problem. Because this is important when you stay on board for a long time. I'm sorry, I go too fast. Do you have any question?
Thank you, Anthony. I mean, this is very interesting because, again, we need, when we're speaking about protecting the ocean, we also need to think about the sustainability of what we put in the water. And this kind of presentation is quite important because we can see how we can make the best use of also the material that we use in order to make the ships.
We can't use fiberglass.
Yeah.
They don't want.
Yeah.
They can't.
And this is also related to the problem that we discussed. I mean, we have to prevent, pollution, prevent delivering.
There is another problem. When we go to the government, because we have made 2 boats, one big and one small, the government say, we don't have money. And we are very, very happy when they say we have just a little, just few money. We are very happy. That's the problem. Aluminum is very cheaper without fiberglass because we don't need a stamp and we can go very fast. And we can make a boat with project in 1 year is enough. And that's important because it's very fast, the production. Okay?
Thank you so much. Thank you so much. And from tools that let us to bring people in the sea, we go to tools that people can use in order to collect information from the sea. So I invite Marco Tampucci on the floor to present on the Nautilus app.
So, hello everyone, I'm Marco Tampucci from the Institute of Information Science and Technologies of National Research Council of Italy, and I will present you our application that we have developed in the ambits of the Horizon 2020 project Nautilus. So, the project aims at gathering data from different sources and to share them as open and free of charges, following the international standard and the European regulation, for example, INSPIRE, and following the FAIR principle. Here, the application that we can see circling in red as treated as a sensor developed as one of the other sensors developed inside Nautilus. And so the data flows to the Nautilus AirDAP server through a set of RESTful API dedicated to this. From here, data can be accessed through the web portal, which offers a bunch of functionalities, such as, first of all, displaying them on a geographical map, and to view them also in a time series, so we can view the data evolving during time of the data. And we can also download the report with containing all data of the activated layer together with several kind of charts. So regarding the data sharing, Nautilus aims at share all the data to the existing and well-established aggregators such as EMODnet. And in these ambits, our application follows all the guideline and the vocabulary adopted by such aggregators. So all the data produced by the app can be directly shared to such aggregators. So the application is developed with React Native, which is a framework developed by Meta and used for some of the most distributed application and platforms such as Facebook, Instagram, and Office 365. And this application developed with such framework can be easily built and distributed for both Android and iOS devices, and can be also built up as a web application usable from all the browsers available. So, thinking to the different background that will have user that use this kind of application, the interface has been designed and developed as easy to use as possible. And so it's very simple and clear. It, as mentioned before, it sends data to Nautilus AirDAP data server through a set of RESTful APIs, which substantially are a set of HTTP request and response to exchange data and information. The application can be easily extended in order to manage other type of gatherable data and information, and it offers also a preview of the previously stored data. So the application opens with a login page. At now, we prefer to keep under control the type of the content of the data that will be shared to Nautilus. So we prefer to have a login page. And after user login, we have the main screen, which offers a bunch of information such as the user ID, how many reports have been shared, and the coordinate of our location, together with a set of buttons used to access to the several functionalities of the application. In detail, the first 4 buttons are used to send data to AirDAP data server. The view map button is used to view the previously stored data on a map, and the logout is explained by itself. So, explain you some of these functionalities. The plastic campaign allow the user to choose one existing campaign, or if user have the right, to add a new campaign. The plastic campaign are cleaning campaign. This campaign involves beaches where are surveyed, and the plastic litter are collected and then cataloged. So if a user wants to create a new campaign, he has to add a campaign name, the date, and the coordinate where it took place, and the length of the surveyed area. Here I don't think that we can see, but the mandatory fields are circled in red. And they follow the guidelines of EMODnet. So along with them, it is possible to add a set of corollary data, such as contributor, location name, beach name, surrounding type, sediment type of the beach, and if present, adverse weather condition. For the last three fields, we use the same vocabularies of EMODnet. The date can be added, as we can see, from a calendar view. Meanwhile, the coordinates are taken from the GPS sensor of the device, but can be edited both manually or by selecting a location on a map. So, on the other hand, if we select a plastic campaign from the list available, it is possible to add the different type of plastic that are found during the campaign. Here, for each type of plastic, we can set the amount by using or the plus or minus button, or by directly typing the number. We can also add a set of images that are significant of the campaign by using the camera of the device, or by picking it from the gallery. The other functionalities regard the other campaign that can be added to the AirDAP server, which are more simple to use. And there are the diver campaign, where divers use sensors developed inside Nautilus. And here they can select the parameter that has been measured by these sensors, such as salinity, water temperature, chlorophyll, and the amount, the measured value. The image annotation instead allows to add the species and the quantity, the amount of occurrences in the attached image. And the algal bloom is an integration of of another citizen science device that will be presented in the next in some presentation, future presentation. That it is alga warning. Indeed, from this device, the value measured from this device can be added not also but directly from the alga warning, but also from this application. Finally, the view map offer a quick view of what we have previously stored, and we have only a little subset of information, because we want to avoid drop performance due to management of a huge amount of data. But we can have a full view of this data directly by viewing on the web portal, the Nautilus web portal, as we upload the data to the system. So, thank you.
Thank you, Marco. Thank you very much. Is there any question from the floor? Otherwise, I will pass the word to Cooper, because he is online, so it's easier.
Let's see if we have Cooper online. Hi there, Cooper. I don't know
Good
if
morning,
you see me.
good afternoon.
I'm wearing
I see you in there.
It's the fish shirt today, right? It's the one you
I
like.
can't see that detail.
Yeah, in honor.
That's my favorite one, Pat.
In honor for this session, okay? Good to see you. So I met Cooper some years ago. He was presenting at a meeting in the Baltic. That's the only presentation I still today remember from that session, actually, a three-day meeting. And we got something pretty cool running, we think, and that's what you're going to present on here today. And thanks a lot. You're on the East Coast of the U.S., so what is it? It's not too bad, right? It's like 9 o'clock.
No. 9:15 in the morning.
So pretty good. Pretty good.
Pretty civil.
So I'll let it over to you.
Thanks for working around the time zone.
Enjoy, have
Thanks.
fun. Stage is yours.
Okay, thank you very much, Patrick, and really wish that I could be there in person. Never been to Genoa, but heard great things. So hope everyone's having a fantastic week. Does this look correct to everybody?
Yeah, looks fine.
Okay, awesome. So I'm going to be presenting on behalf of FV-ON, which is the Fishing Vessel Ocean Observing Network, which is the consortium of scientists, innovators, all of us listed here, working to elevate fishing vessels as a platform for ocean observing to kind of the highest levels of ocean observing. And really that is to become a network under the global ocean observing system, so that this can be a tool which can be used side by side with gliders and Argo floats and buoys and everything like that. And so, what makes fishing vessels such unique vessels of opportunity is really this subsurface data collection capability from the fact that fishing gears are essentially they're performing profiles or transects during their normal fishing operations. And so sensors, which you can send along for the ride, they're going down and then back up. And then as soon as the gear surfaces, data can be relayed with Bluetooth to a vessel hub onto the cloud fully automatically and not getting in the way of fishing in the slightest. So you can see kind of the schematic here, and then also a picture or from a GoPro just off of Peaks Island, where I grew up in Maine, where we got some lobsters pretty soon, as soon as the trap dropped in there with that sensor. And so you'd be right to point out that fishing for data is only going to work where the fishing is taking place. But that's really where kind of the elegance of this solution. And so for the rest of this presentation, we are going to go over some of the GOOS network attributes, which is what's shown in the top panel of all of these slides, kind of showing the pieces of GOOS networks, and so where then we see fishing vessels fitting into this framework. And I think this is a useful exercise for other citizen science and similar initiatives as well. And so, what we see here is filling these key data gaps. And so in this first map of New Zealand, you can see the previous all subsurface data coverage, which is, and so you can clearly see a coastal data gap, which when I first came into ocean observing, this is really kind of counterintuitive to me, that we have more data out in the open ocean than we do in close to shore. And in close to shore, more things are happening. There are more people, more industries, everything. And then that map on the right, this is not theoretical data coverage. This is actual data coverage from the 250 or so vessels catching data as part of the Moana project in New Zealand. And so really, excuse me, complementing that coverage and adding to the capabilities of today's ocean observing networks. So visualizing that data rollout in a different way, we can see how the Moana project has really flipped that coastal data gap paradigm completely upside down. In most places, the blue down there at the bottom, the Argo coverage, that's the majority data contribution. And you can see that while it's not a competition because these are in different areas, the fishing vessel data coverage has just completely ramped up and flipped that completely around. So we are so thrilled with this. But it's not just the Moana project or us here in the US. This is a truly global emerging network, and we're standing on 2 decades of work by pioneers. So EMOLT in the northeast of the United States, and then FOOS actually in Italy, mostly in the Adriatic, by Michela Martinelli. And so amongst all of us, we've deployed this on a diversity of fisheries, which range from everything from massive factory trawlers to artisanal indigenous fishers. And so that is speaking to the global and scale network attribute of GOOS. And then this next network attribute is contributing one or more essential ocean variables or essential climate variables. And so, yes, we are doing that, and we have tremendous capability to do even more. Most of our focus has been on the subsurface physical parameters, but you can put lots of other instrumentation on fishing vessels, and we're keen to expand our capabilities. And we're all aligned in our strategy to deliver dependable, high-quality data, which is what this set of figures on the right with the map and the profile comparison is showing. So this is a network of vessels along the East Coast by my group, centered around the Ocean Observatory's Pioneer Array, which is one of the highest resolution buoy arrays in the world. And then that profile comparison on the right, you can see on the y-axis going down to 700 meters depth. And then on the x-axis, you've got temperature from about 5 to 25 C. And so the crab trap mounted sensors, red and blue, and then overlaid on top is this ultra high resolution, kind of the Ferrari of ocean observing. And so you can see that our humble crab trap mounted instrument is resolving the thermal structure of the water column to the same degree. And a side note, the annual budget for that Pioneer Array is over $15 million a year. And then look at the coverage that we're achieving by just a few fishing vessels. But sustained funding is always a problem for kind of any ocean observing. But framing this in a little bit of a different way, we both have some rather unique methods for funding data collection, kind of coming from creating these data win-wins. And so the example here with this app visualization is from the group in Japan, where they have this custom ocean modeling solution, which has been extremely popular with fishers, who are then feeding that data, CTD and ADCP data. And I think this is an opportunity which can extend to other citizen science initiatives. But ultimately, this kind of sustained funding observation, I want to flip this narrative around, because collaborations like what we're doing, as well as other citizen science, can be so cost effective. So, as a community, we are here to enable sustained and widespread complements to Argo and these other conventional observing technologies by being so cost effective and changing the game in that sense. And then the final network attribute that I want to speak to is, developing a community of practice, which is just what we're doing here, and this presentation speaks to. And we had our first in-person meeting of the FEON group in the lead up to the ASLO meeting just a few weeks ago in Oslo, Spain. We're all thrilled. It was tremendous, and there was great alignment. So we're charging forward. Planning another meeting around ocean sciences meeting in February, and moving forward with creating a UN decade project, hopefully under Coast Predict. So lots of excitement there and new things to come, so please stay tuned. And so thank you very much from myself and the rest of the FEON team, and looking forward to any follow-up discussion either here, or feel free to send me an email or anything. Thank you.
Thanks, Cooper. Cheers from Genoa, right? Thanks for the presentation. Do we have Andrew online? Antonio?
No, not yet.
Oh, okay.
He has a problem with the connection.
Any questions for Cooper? Just to stress that again, I mean, it's so simple. We're just using existing fishing vessels as oceanographic platforms, and I don't know, there's tens of thousands of these things, hundreds of thousands of them around. So let's make use of that. And you're really busy at the moment. We're getting you into being a Goose recognized network. We're getting you into ocean decades and all kinds of stuff. So it's a lot of momentum going on. So I'll let you get back to work. Yeah. Keep the good stuff going.
Keep an eye, because in a couple of presentations, you're going to see a nice tool that you can install on fishing vessel as well.
So we're going to have a fishing link later on.
Giuseppe will tell more about that.
Hang around and wait for it, Cooper.
But before that, something that you can deploy from a fishing vessel also. So, Silvia.
No, thanks, Cooper.
Thank you, everybody. Ciao.
Silvia Merlino is going to present some very nice tools in order to, make a reuse of things that we want to remove from the sea. Silvia, up to you.
March, yes. And, okay. So, good morning. I am Silvia Merlino from Institute of Marine Science of CNR. And I will speak to you about the potential of low-cost approach in marine monitoring. As CNR, together with INGV, we coordinate Sea Cleaner project activities in Pelagos Sanctuary. And, the activities are of different type and are performed with the help of other institutions, of CNR institutes of research, and also ENEA and the LTM and other research institutes, universities, and a lot of NGO and volunteers association and school students. So first kind of activity that we implemented are microlitter and microplastic sampling on beaches using standard protocols and volunteer student involvement. But also macrolitter on the seabed, thanks to collaboration of association as Paz Apnea, that is an association of free divers that collect marine litter with apnea diving. And this year, a big event in 10 Italian locations, including Genova and Marina di Pisa on June 2023, with a lot of participants, a lot of kilos of waste removed. And the special thing is that use protocol adapted from standard one in order to have the possibility to ask the researcher to use the data for scientific purpose. One of the important testimonial was Umberto Pellizzari, that is a very famous Italian free diving that deep in Marina di Pisa waters. And even speaking about the seabed, we also are involved in project with Castalia float for the removal of macrolitter on the seabed in open sea. And in this case, for example, just 10 years ago, we removed 600 of plastic bottles from a place near the Giannutri Island, that is an island in Pelagos in the Toscana Archipelago National Park. These bottles have been found in a very, very small areas, and till now we don't know why there are in these places, are all plastic bottles. And the interesting thing is that they are covered by and colonized by polychaete, foraminifera, and other kind of bentonic organisms. So now we removed completely this accumulation of bottle, and we are studying them in order to understand the degradation of the plastic, so to understand the time that they are fall down in this place, and also the modality of this kind of colonization, and also to search for alien species, to understand if they came from another place or not. And also, now I will explain you how. The next study are to understand the marine current in this place, and if the modality of these strange things. So for this activity, we are supported also by police. There are a special police that do underwater activities of La Spezia that help us, so citizen science activities. And other kind of activities are, for example, started during the COVID period, so our virtual survey program for school and researcher during lockdown, using aerial drones and informatics GIS tool. In this case, after the photogrammetry to acquire orthophoto with the UAV, the students analyze the images with QGIS and quantify, characterize the marine litters and classify them by material type, size. And so it is possible to obtain with the waste accumulation rate with different dates and different, so we studied the spatial and temporal dynamics of the marine litter. Not only we count them in one date, but really during 1, 2, 3 years, we have information about the modality of the dynamics. Now I would like to show you this, because we developed this prototype of marine litter drifter, so are trackers, to track movement of trash outcoming from river mouths and study the dispersion in the sea, in the coastal areas near the river mouths. The marine litter used during dispersion experiment have been realized by us, but also a very simple modality to realize this and very cheap. And in one of our projects, because some of our projects are inside, for example, Nautilus European project, or Blue School Med project, Blues Night project, Marta project, all are European projects that help us with financial part of this kind of activities. One of these, the Blues Med school project, involve a student of high school to deal with activities that have to be with the sea. And so we propose them to build this kind of things. And during 1 year of activity, they realize different type using real trash. Real trash from the beach cleaning. And here I don't explain you because it's too long, but there are a special informatic and electronic device that we realized, so it's original. And with this, it's possible to follow the dispersion of marine litter, and it's really very very cheap. And so we realized a lot of this dispersion experiment with the help of police, and we obtained tracks in the Pelagos Sanctuary, so we can follow the dispersion of marine litter and to understand where they go to strand. And another low-cost prototype that we realized is a microplastic sensor developed in collaboration with CNR Ecom of Pisa. It's a sensor that uses cheap photodiodes. And so with 3-4 photodiodes, it's possible with this sensor to distinguish about the organic part and the polymeric part, directly mounting them on boat and also on this kind of drifter. That is another kind of drifter, more not so expensive drifter, but with a float of this drifter, and with this sensor it's possible to monitor a large area, and so to have information about microplastic directly with this device. And so this is the last slide. I only want to stress the potential of low-cost approach that now is possible thanks to combination of IoT, smart technology, and also citizen science. We are very happy of this approach, and we involve a lot of people, a lot of schools, a lot of associations, a lot of research institutes, and we did a lot of publications, special scientific publications. So I think that it's real a new approach to follow in the future. Thanks for the attention.
Thank you. Thank you very much. If there is any question from the floor, otherwise I would move to Giuseppe Manzella to present on the blue pack system that you can also try and see, downstairs. You need to book the experience, but you can do that. Up to you, Giuseppe.
I need this one. Okay, so this is the presentation. You can see some names. So there is a mixture of senior people and junior people. Essentially, there are some senior engineers, some young, junior engineers, and there is one old oceanographer. And in some sense, I am the grandfather of the group. So essentially, this is a portable laboratory. We call it a blue box, and essentially all the concept of the blue box that probably you know very well is inside our system, our portable laboratory. And it's essentially an integrated hardware and software system that essentially the data transmitted in real time is an IoT system that essentially is collecting data that are fundamental for the knowledge of marine environment. Okay, so next one. So this is the box. The idea was essentially to have a portable system, so essentially you can just carry on board any kind of boat is good for this system. Can be inside the boat or outside the boat, since it is waterproof. And you can see there are also some tubes, so essentially the water is pumped inside the box. There are sensors, they are analyzing the data. The data are then geolocated with a GPS, and the data transmitted in real time in a cloud system. So essentially, you can receive the data in real time, even on board, if you have an internet connection, of course, otherwise. Actually, so essentially, we have data in real time, georeferenced, interoperability is assured. And this morning there was a presentation about the necessity to have an interoperability. We use standard vocabularies. Standard vocabularies for us are essentially CDataNet vocabularies for the people that is using that. And for what is concerning the quality assurance, quality control, we have some software that was developed by us, also roughly presented this morning. But in any case, all the software is done by using UNESCO best practices and ISO standards. So this is essentially what we do. Okay, what we collect today? Today we collect the temperature, salinity, chlorophyll, blue algae, oxygen, pH, and redox, and conductivity. What we want to add in the near future. So essentially the idea that we have is that the system has to be plug and play. So modularity is an essential element of our system. So some sensor can be changed depending on what is requested for the monitoring of the sea. Oh, sorry, yeah. And so our idea is essentially to add new sensors in the future. And this is just a small example of the data that have been collected. So essentially there are, you can see essentially our boat that is the Antonio boat. But you can see from the terrace, it's just below. The name is Fusher. So with the Fusher boat, essentially, we have collected a lot of data from Monte Carlo to the Elba Islands. And you can see here some of the points where the data have been collected. In real time, you can receive all the information on the data. So essentially, the salinity, chlorophyll, blue algae, oxygen, and so on can be shown to you in real time when you are on board. So you can decide what to do during the monitoring. And these are other examples. Essentially, this was done in not much far from here in Sanremo. So essentially, this was a collaboration between us and an organization that is called TETIS. They are essentially working on looking at the whales and dolphins. So essentially, while they were essentially looking for dolphins and whales, we were collecting data. And you can see essentially what we collected during 2 days. Was just 1 month ago, anyway, so was not. Okay, so essentially this is the blue box with the tube. This was essentially one of the boats that we used, and these are some dolphins and whales that essentially were seen during the data collection. There were many questions this morning about data availability. So the data are available? Yes. And the answer is yes. Essentially, in the framework of what is called the Innovation Village, Innovation Village is on the ground floor, essentially, we developed a system that is called Adopt Miles. So everybody can go in our system, adopt just 1 square mile, and all the data that are in this mile are sent automatically to the person that has adopted the mile. So this is essentially one possibility that we have created to deliver the data. There could be also collaboration between us and the people that is interested. And in any case, with Modenet, we needed to discuss how to move the data from our system to another one. And if you are interested to receive data, just adopt a mile. And in any case, we have also here, just coming back to the first slide. Okay, these are, as I said before, senior and young, senior junior people. Our CEO is right there, is Francesca Intes. So if you have questions, just ask to her and not to me. That's all.
Thank you very much. Is there any question? Yeah.
Thank you.
So Francesca will reply.
So how are the sensors put into the water, and can you...
No, the water is pumped inside
okay,
the sensors.
You have a tubing going into the water.
We can decide essentially the depth of the tube, essentially. Actually, we work at 1 meter depth, but we can put the tube down to 7, 8 meters.
Okay.
So we can decide what to do.
And do you have a weight, or is the boat needs to be stopped, I guess, to... the boat can
you go
continue.
underway.
Okay, and pump.
And you can decide essentially the time interval.
Okay.
It could be 1 minute, it could be 5 minutes, or 1 hour. So you can decide the sampling time.
So you have a weight that brings the
yes,
tubing
of
down?
course,
Okay.
yes.
Thank you.
And in any case, the question that we had with Stefan was essentially the speed of the boat. Actually, essentially our system is working very well with boats with a velocity up to 5 knots. We don't know what could happen. Probably something has to be changed if we want to reach a higher velocity. But anyway, the concept can remain always the same.
Yeah, thank you.
You're welcome.
Is there any other question? Maybe you can be interested in, hosting while. Okay, so thank you very much. And now we have another amazing presentation from remote. We have Fernando, that is also setting up a very, amazing way to collect, environmental information. Fernando, are you there? Yes.
Yes, I am.
Okay, so,
Right.
I don't want to spoil the nice stuff that you're doing, so I give you the floor. So you can share your presentation and then we go.
Okay. Can you see? I was not expecting to talk next, so I didn't have this in the first slide. Okay, can you see the presentation?
Yes.
All right. So with this impending, well, first of all, I'm Fernando Lima. I'm from the University of Porto, and we are running this temperature and biodiversity observation network across the entire Atlantic. With the impending climate and biodiversity crisis looming over the horizon, it is really important to understand the link between climate and biodiversity. But when animals and plants, they really don't care about the global average temperature rise, which is 0.2 degrees Celsius per decade. They care about the conditions where they live, at the scale of their bodies. And the environment at this scale has enormous variability, and the biodiversity is also very different from one place to the other in all these microhabitats. And all this fits into a pixel of satellite data set, data point. So how can we measure all this variability across very large scales? That's the issue. Here on the left, you can see a thermal map of the intertidal, and you can see that there are blue colors represent colder surfaces, the red colors represent warmer surfaces, and there are differences of 15 degrees here just on this picture. And this is just a small area, and we need to understand this in order to understand what is going on. If there are climate refugia, for example, why don't animals just hide there? What is the big deal with the climate change? So we need to really understand this in order to understand the processes and predict the future. On the right, you can see also that measuring biodiversity is not easy, because in the intertidal, there's a lot of species in a small area, and identifying all this and quantifying is very, very hard. But if we don't do this, we have a situation analogous to a burning library where the books are being burned and we don't even know which books are there. So this is really worrisome, and we need to understand this. How can we do it? There are major challenges regarding the feasibility and also the cost. But this microhabitat frontier is something that we must explore and go beyond the current state of the art. So to measure temperature, we have developed these temperature loggers that are very small. I don't see, you don't see my image, but in the screen, you can see that they are like the size of water bottle caps. And there are a variety of shapes, but we use the disc ones for this project. What is really nice about these loggers is that they last for 15 years, totally autonomous. So they have battery and memory for 15 years, recording temperature at every hour. They are quite precise and accurate. They are very cheap compared to other systems. People deal with these loggers by using their smartphone, so it's very simple to program and download data. The communication is powered by energy harvesting from the phone, so that's how we get these enormous deployment times in autonomy. Data is non-real time because you have to go there and download data with your phone, but because they last for so long, we can take this deploy and forget strategy, for example. And most importantly, this provides us with a standard way of measuring temperatures across very large scales. They have been used in land, in the ocean, from tropical to polar regions already, and they facilitate these distributed networks, large scientific networks. They can also be used as time vaults, and they have a great potential for citizen science. Now, what about the biodiversity? The biodiversity is also very hard to measure, even harder. What we have done is to create this app, smartphone app, where we decouple the field data acquisition from taxonomic identification. So we have someone in the field acquiring the data, and someone else will identify the data back in the lab. So by doing this, we can do biodiversity surveys very quickly, and the person that is collecting the data doesn't need to be an expert. We can include people in the network that are not with just simple training, and we use the phone sensors to collect a lot of metadata automatically. So this is quite error-proof, and all those data are embedded in the EXIF fields of the pictures. So it's impossible then to scramble or to mess up the data because everything is organized from ground up. Again, this provides a way of standardization, which is really important. And with these two tools, we are building this coupled coastal temperature and biodiversity observation network. It's the largest of its type on Earth. It's fully funded now. We have 160 locations, both margins of the Atlantic. We are collecting our hourly temperature and yearly biodiversity surveys with our collaborations in all these locations. This infrastructure will be running for the next decade. It has a distributed network, open data, but with authorship attribution. And again, standardization is always the key term here in this initiative. So the main objective is to understand how coastal temperature varies across multiple scales, how it determines coastal biodiversity, the patterns, the current patterns and change. We focus on resilience, spatial comprehensiveness, standardization. It's based on a large network. It's expandable and it's AI ready because all data are being collected in a non-destructive way and can be analyzed in the future by artificial intelligence. Also, the data that we are collecting are being annotated by us, so it will be easy to move to the next to do this next step. And only the sea surface temperature data that we're collecting is tremendously useful for numerical modeling or for climate analysis, not to mention the rest. This is just an example. So we drill holes in the shore and we deploy the loggers inside the rock. They are really protected and we don't have, the loss rates are very, very minimal. Then data collection is very easy. It's done with the smartphone. It can be done even by, this is my daughter, 4 years old at the time, and she could do this all without any instructions. It's very intuitive. And this is the other part, collection biodiversity data in the field on the left, with the smartphone as well, with a simple quadrat. And on the right, you can see all the metadata that is automatically gathered by the smartphone without any user input. So this is very easy to do, and also it's less prone to errors. And we are collaborating with fellow scientists, with park rangers. For example, here this is a training session in Patagonia with park rangers and with local people, as here in Cabo Verde on the right. And this is just the overall timeline. We have just finished the hardware part, the infrastructure. We are still deploying loggers. We are maybe 1/3 of the way in the logger deployment. We are finalizing all the protocols. Then the next step is to have this data coming automatically to our servers. We are working on that at the moment. And in the future, from next year onwards, what we want to do is to involve more and more people, the citizens in this. For example, here on the corner, you have a picture of a wearable of these loggers. Then you have these streamlined loggers that are can be used by seagoing people that are people that have small vessels and can attach this to the outer hull of the outer of their boats, the other side of the boats. And we are involving we are doing bio-blitzes as well, and that's it basically. I leave you here my contacts, email and Twitter. Also this website, Coastal Warming, and our startup where we make the loggers. And thank you, I'm open to questions. I forgot to say thank you so much for the invitation. Unfortunately, I couldn't go. It's a pity. I really wanted to be there with you guys. I hope next time I can do it.
Thank you, Fernando. Just to let you know, we have a couple of these outside here. It's close to Portofino, right?
Yeah, actually,
nice.
we did the very fancy stuff because we plugged some of this sensor in a rope so we can get a sort of profile, a time series and profile at the same time. So we are asking, kids to go there and collect seawater temperature at a different depth, just collecting the rope.
And we do something similar in Sweden too. So we're using that sensor. We put them on for comparisons. We put them on our most expensive platforms, and they're spot on. So this is incredibly fun. And I just want to give a big thanks to you because you have been on basically every one of our shows except for one when you were in Patagonia and deploying these things, right? So yeah. Thanks a lot because you're one of our regulars now to our workshop.
That's right, Ismail. It's a pleasure.
But we're really happy that you do it. Do we have any questions from the room here? Anyone? Any questions around? And thanks a lot also for giving me a couple of these samples. Yeah. We're using them both for checking water temperature, but also air temperature. So yeah. It's cool.
Yeah, we are having fun with those tools. And this is another good example of citizen science. It also, because they facilitate also to teach that, we have seen also from Silvia, some kind of tools that can easily use with kids, and this is another one, yeah.
So thanks a lot. We'll be in touch very soon, again.
Thanks. But you said Portofino?
I said Portofino.
So Portofino. So we invite Arianna on the stage to talk about the activity that we're doing in Portofino.
We have Portofino in the house. Very good.
Cheers, thank you. We have actually been using also the M-vloggers, but we left them, so with each boat that we equip with citizen science sensors, we put the M-vloggers on the surface and at the bottom of a rope, and we leave them at the harbor where the boat gets in the harbor. And we leave them as long as the boat stays in the harbor, and then we move to another harbor and we stays there. So it gives like a nice idea of like the water column. But anyway, okay, so very excited to be finally in person here because I attended the previous like data chats, but I was always on the screen, and now I'm out of the screen. So excited to be out of the screen. Where do I have to click? There we go. So I'm Ari, nice to meet you all. I am usually in a situation which looks kind of like that. I'm usually typing on my computer, but in a marine situation. I'm a marine ecologist. I was born in south of Italy, but then I did all of my education and university in the UK, and then I moved back to the Mediterranean Sea to serve it. And now I'm currently working in citizen science projects, and in particular I'm working with Outdoor Portofino here in the local area, and with Outbe, which is the startup that I'm also going to be talking about today. So first of all, I'm going to ask you a question. Has anyone ever seen or knows which one of these animals this is? Can anyone tell me which animal this is? A moonfish, okay. Okay, or a sunfish. It depends which language you speak. Okay, it's either, okay, in Italian we say it's a moonfish, un pesce luna, but in English we call it a sunfish because it likes to lie down in the sun to get rid of barnacles and seaweed, okay. So everyone knows what this fish is, and I'm pretty sure if I ask sailors out in the ocean race, they know what this fish is because it's a common sight. I am a sailor myself, I see it all the time with its like funny fins out of the water. The only thing is that the IUCN red list, it doesn't know where this fish is because, as you can see from this gray bubble here, this fish is considered data deficient. Scientists do not have an idea where this fish is present in our waters and if it's threatened or not. And this is a problem. This is an animal that is commonly seen by people who experience the ocean, but scientists do not know anything about it. So this is the thing, like we're all here because we're in search of data, right? But protecting our ocean is a matter of understanding it, and scientists are not enough in order to collect it. This is why we need scientists. This is why we need citizen scientists, but at the same time, who better than the people that are out in the water every day, that live the ocean every day, for example, sailors from the ocean race, to collect this kind of data. And they can collect evidence that we really, really need for marine conservation. And at the same time, the more we live, discover, and understand the ocean, the more these people, they increase their ocean literacy, they become aware of what are the problems of our ocean, and they also increase their well-being. And we all increase our well-being because, let's be clear, we all go in the ocean because it's amazing. We love it. It's the best feeling on earth. It's our blue mind. And this is an important thing. It's not just the data, like the benefit that comes from collecting data in the ocean, but also it's the benefit from being in the ocean itself. And this is what we are trying to share. We believe that only if we leave the outdoor with curious eyes, we can deliver health and well-being for us and our planet. So it's a health and well-being which goes in both directions. And how do we do this? So thanks to EMODNet, we've been training different outdoor centers, so centers in which people can discover the outdoors both via sailing or via kayaking or swimming, so all the activities that you can do outdoors. So we train them in the different citizen science projects, which, thanks to EMODNet also, we are discovering step by step. And if you're one of the citizen science projects that you think we can do while we do outdoor activities. For example, mVlogger was one of the projects that we discovered via EMODNet, and we got on our ecosystem. Then I invite you to come and talk to me also after the presentation. So we teach the outdoor centers how they can do these projects while they do the outdoor sports they love. And then it's time for action. So for example, this is one of the projects that we started out in Portofino, Marine Protected Area, and it's called the Mini Microplastic Hunters. And what we did, so basically it's usually really hard to monitor for microplastics nearby coastal waters where the coastline really races very sharply and is not easy to navigate with propellers. And so we invented, together with CNRIS, we developed a small version of a tiny manta troll to get carried and trolled via kayaks. And this resulted to be amazing because without the propellers, we collect more microplastics than with traditional manta trolls. So this was actually, we're now in the process of publishing the paper, so you're going to see it out in the next few months. So, well, okay, science times, so it's going to be soon. But yeah, it was very successful, and we really hope that it's going to be authorized also by the EU Framework Directive, because we think this is going to be the next way of sampling for microplastics, and not only for microplastics maybe. And then we're now in a sailing event, so I want to talk to you also about what we're doing in sailing. So this boat here is a 6.5 meters boat, which is called the mini boat. And it's the smallest racing boat that there is around. There is no toilet inside, there is no kitchen, there is nothing. It's the smallest boat with which you can single-handed cross the Atlantic. You can see them actually down here. There's the mini class just down here. We are equipping one of these boats, which is going to cross the Atlantic this year in September, with sensors to monitor for ocean parameters. And it's a very big challenge, because it's super easy to equip an IMOCA or a VR, because they're huge. You can do a hole in the boat, you can pump the water in, it's okay. It doesn't matter if it's heavy, it doesn't matter if it costs 10,000 euros, it's okay. They have sponsors, they have room, they have weight, but here you have to be careful to everything. You have to be careful to drag. And so if you can equip a boat like this with low budget, you can equip any boat. You can even equip a kayak. So it's a big challenge, but this is what we are working on at the moment. So this is going to be the trail that we're going to do. We're going to live from the Les Sables d'Olonne in France. We're going to go to La Palma in the Canary Islands, stop for 3 weeks, and then go across the Atlantic to Guadeloupe. It's a long way. Let's hope that all the sensors stay in place and they all work. It's a stress test, but this is why we're doing it. They're all prototypes. So this is one of the prototypes, is the super previous prototype of Breezer, which Diana is going to talk about later. It has a tail that dips in the water and collects data as we are sailing. And I'm going to show you better pictures of, this was like the super previous prototype. So you can see it has like a waterproof case, and then everything is like out in the view. And then it has, this is the trail, and you can see the data that we've been collecting every couple of minutes via the trail. So this is Breezer, collects temperature, atmospheric pressure, sea state, and is geolocalized, and is very accurate with this geolocalized session. And you can easily attach it to the end of the boat, and is both for more leisure boats, but is also good for racing. And then you're going to have, in the next interface, you're going to have a very cool interface where you can share with your friends, like, okay, this is the track that I've done via my racing or via my, I don't know, exercising, and this is the sea temperature of my track. So this is what we want to achieve. We want to achieve something that is cheap, that you can easily put on your boat, and that you can easily share your data, and they go directly where they need to go for scientists. And then at the same time, we also put another sensor that we've been testing, which is the Astrolab Expedition sensor, which is called SenseOcean. So this also collects salinity, and it's slightly different than the one that we've been developing, the Breezer one, because it's not linked to the energy of the boat. So the previous one is linked to the energy of the boat, and it only consumes a little parts of the energy of the boat. It's literally you don't even feel it. Well, this one has a solar panel on top, which is a pro, because, I mean, you don't have to link it to the energy of the boat, but a cons because it occupies more space and is more prone to breakage, because, I mean, there's a lot of ropes on a racing boat, and we already had to install it in a very special position. And it has a screen where it gives you instant feedback of the temperature and the salinity, so again, it's a little bit more like leisure style. But it's working, and we have one on the side and one on the other. So in case one breaks, we have the data also from the other one. And then, so what is happening to this data? We all know what is happening to this data. It's going, so the future is, once we've been testing it, they all go into EMODnet, and they help us to model our climate forecast, and in theory, then helping us to model our future politics decisions, and then our daily actions. And it's amazing to see, when we talk to sailors, we say, the data that you're collecting right now can influence the daily actions that you do the next day. And this can make a very big difference. The other thing that we're doing on board is also collecting sightings of marine mammals and debris, for example, and we're doing this through, for example, iNaturalist in terms of the marine mammals and how we do it. When we are racing, we cannot have any connection with land, so we cannot use our phones. If we cannot use our phones, then we use our GPS. We write down the latitude and longitude, or we use cameras with GPS. And then when we are back on land, we log everything into iNaturalist, and we'll let everything known to the scientific community. Then everything goes back into a big report that we also give back to the funders of the project, and it's very important to let them know like what is happening. And then another thing, like I know we're scientists, we don't think a lot about storytelling, but we're also storytelling all the way from what is happening to the sensors when we're building it onto the boats and everything, and then what is happening onto the racing part during the regatta. So if you want to follow us, we are on every social media you can think of, and we're storytelling all the way through. So this is what we've been trying to do. If you want to be one of the citizen science projects that are involved and taught to the different outdoor centers and outdoor activities we're involved in and join our community, then please, there's a QR code in the next slide. But first of all, like, thank you so much for being here and for listening, because we are working as the ocean is. We're working all together and without borders, among sailors and among industries and among scientists, and it's wonderful to see this kind of union. Thank you.
Thank you, Arianna.
Thank you.
If there is any burning question, otherwise, as you mentioned, some of the tools that you're using in this ecosystem, I would like to call on the floor Diana to present on Brizo. Yeah. This is a very nice, as already presented, as it is already news in many, citizen science application. We can dig a bit more into how it works, how it looks like. So, Diana, floor is yours.
Thank you very much. Hello, everyone. I'm Diana, and today I'm presenting Brizo on behalf of O Engineering. So let's start. Here? Okay. So the climate is changing, and every day brings more evidence. But we have a powerful ally, the ocean, that already absorbed 93% of the excess heat since the Industrial Revolution. Without it, today the temperatures will be almost 50 degrees higher. And we will be just like this chicken over here. So we are safe, but not really, because the ocean also is warming up, and we are risking to lose our best ally in climate mitigation. So we only got two options. We can cry, or we can act, like always in life. We decide to act. So, but how can we act? We decided to monitor the cost by gathering ocean data to help research and ocean protection and conservation. And we decided to monitor the cost because it's not so easy to monitor the cost by satellite, because we have to go much more in detail of what happens like in a small scale. And we decided to do it with citizen science. So Brizo is a sport tracker that lets you turn your water adventures into valuable data for science and conservation. And how does it work? Brizo collects data along a route. And by playing your favorite sports like kayak, canoe, other sports, you can track your data, your sports data actually, like acceleration, roll pitch angles, and also your environmental data like water temperature, or meteorological data like wave motion. So with Brizo, water sports lovers can monitor and boost their performance, but also advance scientific knowledge, support conservation efforts, and improve navigation safety. And we imagine for the future to have like a fleet of Brizo sailing around. And the ultimate goal is to create a global community of water sports lovers who share their passion and data to inspire positive change. We tested with different sports, and the first people of this community were also the people who tested Brizzo with different sports. We can see also Arianna over there, and the last one, a test we took in Sardinia with Valeria as well. So we tested by sea kayaking, but also by sailing in long distance, by river kayaking, and we gather much data of different types, like water temperature, acceleration, magnetic field, angular velocity, pitch and roll angles. So we have very much potential about this project. So after many, many tests, we also collected some user test data that were really useful to decide the product requirements of the new Brizzo. In one hand, we decided to improve the user experience, so the new Brizzo will be easy to use, small, attachable, not distracting, but also it will have like a marine aesthetics, and also it will be durable for circularity reasons, easy to disassemble, repairable, upgradable, and we will use rapid prototyping to do so. So the new Brizzo will have like two probes, an atmospheric probe and a water probe, and it will be modular. This is important because we need to be able to replace the probe, to repair the probe, or also maybe to update it and to collect other kind of data. We decided to have a very simple interface and to have then an app to have a better experience. And the new Brizzo will be also adaptable to different sports thanks to an attaching system. And okay, but let's go more in detail. She's Odin. She's a ceramic designer and a friend of mine. She has a very high level of eco-anxiety, and she's not like a sport person, but she loves nature. So she decided to try Brizzo. So after a briefing phase, she can turn on Brizzo, she can pair the Bluetooth, and she can start her experience. She can go to the water, she can enjoy the activity, but also she can see the data in real time. So she can feel useful, but also she can really, at the end of this activity, she can have a debriefing with all the team, and she can also notice that she's not alone, like she is really in a community of people, and she can see all the data collected by the team during the experience. Then she can also maybe achieve a prize, like she was the slowest, so she collected the more data, and she can get maybe a discount for the next activity. And then at home, she can consult the road history, she can also share the experience, share the data in her social networks, like we do maybe with Spotify. And then she can consult the general map, and really she can feel that she's part of something bigger. So what's next? We understood that Brizzo has many benefits, like it can be really useful to help sports performance, but also to science research and to navigation safety. Also, Brizzo can be really important to help blue economy, coastal management, and tourism, and to help people to build a sense of citizenship. But we have some challenges, like we really need to improve the usability, the circularity, and we know this because we are actually starting to produce the new Brizzo very soon. So we need to develop this app, we will develop the platform, and also we need to build this community of allies for doing so. And then in the future, we imagine that Brizzo can work as a service. We can build up some challenges, like which you can maybe have a challenge between nations or between friends or schools, and also that we need to visualize this data in a catchy way. And then we can use Brizzo with other sports or maybe with other data. So if you wish to stay updated with Brizzo, you can scan the QR code because we don't have much time and the oven is approaching. Thank you very much.
Thank you. Thank you so much. Yes, Jay, coming.
Thank you for a very interesting presentation. I'm interested in your model where she gets a discount because she had more data. Are people paying to participate with you, or how do you, what's your business model?
This is just like an imagination story, but we can imagine that Brizzo can work as a service, like maybe an outdoor sports center can have like a fee for a month to rent Brizzo, but also we are building up the real model, like the financial model. It's not something real right now.
Okay, I have a second question. There was interest in having an array of low-cost sensors that modelers can use to predict the local coastal environment. Can we take these and throw out 1,000 or 10,000 of them and let them just float around rather than being on kayaks?
Sorry, I didn't understand.
Okay.
No. They are rechargeable, so they really have a battery, so we can't just keep it there. Okay. Thank you.
Okay, thank you very much once again for the nice presentation. And then we were discussing about some surface data, but I mean, the life in the ocean is much, much more. So we also need to have a look at what is happening in the deep ocean. So I would like to invite Ennio Ottaviani to present on Guard 1.
Thank you very much, Antonio. Okay, this one. Okay, this is Guard 1. This is our products about it. Okay. Okay. Quite different product, this one, because we're speaking about observation of the environment, underwater environment, directly by sensors. So Guard 1 implements a new idea in which camera and artificial intelligence goes together in order to understand autonomously the environment. My company, On Air, is on the left. We own a patent about this product together with CNR, which conceived initially the projects. The product is currently manufactured by O Engineering on the right. So you have seen the Brizzo one. This is the same company. We have a license in order to product and distribute this kind of product. Just a few words about the past. What about vision underwater? Yes, may be very useful for many activities like monitoring biological diversity and population of fishes, of course, eutrophication. Many phenomena can be characterized by software. So, CNR works on this type of projects for many, many years. Here you can see some picture about the typical mission performed by CNR researchers in the last year using computer vision underwater. From all this type of understanding, we perceive the need to put algorithms directly inside the camera and realize a computer project that goes underwater and stay there for long, long missions, even many months. And this is the outcome. The final outcome is a device which is completely standalone, can be programmed before the mission in order to execute some kind of data processing on images and perform this every time having its own battery, and so the source of energies is provided by the system itself. If you are interested in this type of system, I invite you downstairs where we have a stand, which the device, and we have plenty of videos of several missions in which you can see how the device works directly on underwater. From a technical point of view, the system is an embedded computer. That means there is a CPU, a computer processing unit, connected directly with the camera, a lighting system, and a communication system in order to provide data outside the Guard 1. Of course, if it's possible. Not in general, we may think to our system like a completely standalone one, which is able to perform analysis on data and store them locally in its storage, but we cannot communicate outside if we do not have sufficient bandwidth. But if we have bandwidth, we can communicate outside the system, small messages, images, or even video, if you have sufficient bandwidth. The power is provided by the system itself with its own battery, but if you have an external source of power, of course, may be better because we don't have so much constraints about the power consumption. But in general, the system can operate totally in an autonomous way. Here you can see the system and an inside view on how the system is built up by electronic boards and a very big battery pack. On the bottom, you can see some typical images acquired by the systems and processed on board. The system has its own lighting system, so we can have also nighttime images that may be very useful to analyze an environment during the whole day. From a computer science point of view, the system is a closed loop operation in which acquire images, analyze them, and decide if images are interesting, and then store, or no, so they may be discarded. And this is all I can show you. This is important to say. At present, we are plenty of application of artificial intelligence and deep learning for computer-based image analysis. GARD1 implements a new deep learning approach to recognize fishes, jellies, and whichever do you need to recognize in images. The only condition, we may have example instances of what you are going to search inside the water. But having sufficient material, we can train a system and deploy a new computer programs able to recognize, for instance, a new species that may be interesting. This is a typical deploy of the system, perhaps not really a best practice of this, but in general, the system is deployed on the floor and covered with something in order to keep it fixed. Oh, sorry. And this is the typical outcome. Sometimes a fish passes in front of the system catches him, tag this image as an interesting one, and keep it apart. And then we can use it to provide you an overview of the underwater environment. But if you want to go deeper inside the system, you can go downstairs and take a look at it. We are happy to show you more information. Thank you very much.
Thank you. Thank you very much. Yes, I was going to say the same. Please, we say once again that the system is available downstairs. So for each and everyone that is interested in having a look at the system, you're welcome downstairs. So if there is not any burning question, in the interest of time, I would like to pass the stage to Peter. Peter, are you online? We are getting back to the surface.
Yes, I'm there.
Yes, good. So we see.
I lost track of
now we see you. How are you doing? We're missing you, Peter. You're missing something.
No. Next time. Next ocean race.
Okay, so it's in 4 years' time. You have time to plan it. So, Peter, you're going to tell us about the activities that you're doing with the ion water application. So, stage is yours. We see the screen. Go ahead.
Excellent. Yeah. thanks for inviting me for this short talk. And I'm going to tell you something about the concept that we, as Maris, for which I work in the Netherlands, we run now for about 7 years, and it's about observing the ocean, the water, in actually really its simplest form. We observe color and transparency. Some background that, we've seen that in all presentations. Researchers, we monitor the seas and inland waters for a long time via in situ, so on location, local monitoring systems, observation satellites. We make long-term data collections, sometimes really structured, sometimes really on project basis. All observations, in the end, we want to have them contributed to knowing more about the state of the water, marine pollution, climate change, etc. But now, and we've seen already a couple of examples, we also have the smartphone already for a long time, and more and more you can use that to make additional observations, both from like a naturalist already named, and there's all other kind of AI supported systems. But this one, Eye on Water, was born from an idea of Marcel Wernand from the NIOS, who unfortunately passed away. But in his heritage, we keep this Eye on Water concept developed in the project Cyclops, running since 2016. And it's simple. You just observe with your camera on your smartphone the water color and its transparency. But the concept itself is expandable to also with more additional devices. For example, while monitoring pH or nitrate or other phenomena like water plants or plastics. And in the end, it provides a bridge, because it's so simple, a bridge between science, government that wants to know more, the policymakers, and the citizen who can actually contribute and learn. So how do you observe and why do we observe watercolor? Well, it was done already since 1889 using the Perot-Uhle scale. They divided the watercolor in 21 colors, from dark brown that you see at the bottom left there, and the dark blue that you know better in the Mediterranean. We don't know that in the Netherlands. We have more the greenish brownish stuff that you see underneath. But it tells you something, the color. If it's greener, there's more phytoplankton. And if it's bluer, there's less phytoplankton. And actually it changes. Many people see their sea many times and they think the water is often the same. But over time it changes. Some waters get greener, some waters get bluer, sometimes even in the season, especially if you look to inland waters. And therefore we developed the Eye on Water app. And we wanted to keep it simple, collect data, store it, validate it, share and learn. So we have an app, we have a website, and we have some additional services. As I said, how it works, you take an image of the water, you follow the instructions in the app, then you select the area that best fits the watercolor with less glint and reflection, and then you compare it to the 21 colors. You choose the one that is best, that fits best. And then you add some additional information. For example, is there cloud cover? Do you see the bottom? Actually, if you see the bottom, then there's an invalid observation, because then you see the color of the bottom and not the color of the water. But okay. And then you press send, and then together with information about the smartphone, its lighting settings, its GPS location, very important, and the angle by which you've taken it, it's sent to the server. And what happens then is on the server, we run a validation, and that's a kind of image analysis written by Hans van der Woerd from the VU in Amsterdam. It's called WACODI, but you don't have to remember that. And that actually checks also from the extracts also the colors from the image, and also adds a value to the image. And then you can actually compare how the user did it compared to the machine. Then everything is sent to the server on eyeonwater.org. And there you get an overview of all observations. You can make selections over time. You can actually see others that have been in your area, for example, have been taking observations. If you are registered and you request to do that once, you can do it anonymous. But if not, then you can actually see all your own images, and actually you can also get a ranking. So the more you observe, the higher your ranking is, and you can see yourself mentioned as the top contributor of the month or of the week. And then, as you said, we do some validation as well. We do a validation on the import. If the Wakodi value is so the automatic value gives an analysis that is really off watercolor, then it gets flagged, and also other users can flag it. So if you use it and you see an image which is definitely not water, or there's a boat on it or whatever, you can flag it, and then there's an automatic notification going to one of my colleagues. They see it coming in and they remove it immediately. Yeah, so this is an image taken from close to where you are now, in the Mediterranean. You get an idea here of the metadata. Well, we see the values, one from the user, that's I think value 2, and the machine says value 1. Wow, it's really close. So, and then there's you see which device and which was there rain, or was the bottom visible, that kind of information. And then we also have an additional service, more for the techies. We also have WMS and WFS services, so that you can actually load it if you're researching, and load it in your GIS program. Or there's the simple one is a download service where you can get the data downloaded in a CSV format. By now we have about 14,000 observations from hundreds of registered participants. Many campaigns have run already. Some we know, like CSRO Australia, which was a partner of Ion Water for a long time and a sponsor, and we've been making some really nice spin-offs. Ion Water Australia, where they also use a backpack additional to the watercolor, so a backpack to measure these additional parameters. There's research in New Zealand lakes, and also currently a campaign in one of their lakes, Lake Wanaka. And there's also some that we don't know, because the app is open, the website is open, so everyone can use it. It's completely free. Also for outdoor Portofino, by the way. There's one campaign also coming that I know of, is in Lake Geneva with the EPFL, the university. And we're going to develop a French version for that as well. And we're going to have a new website layout, but that's for later. And yeah, these are examples, before I close, these examples of that we sometimes research happens and we don't know. This was in Kalimantan. We saw a lot of data coming in, and there was apparently a campaign, and you can see very nicely the flow of the water into the seas, and you can see it from getting from brown to green as you go out. And you could actually use this to validate, for example, remote sensing data. Another one is a campaign, and there's a lot of data on top of each other. Here, there's more data than you see as dots. In Portland, US, where also we know a community has undertaken this for several years, and then brought their whole collection to a research organization and say, okay, this is what we want to know more about the state of our environment. So yeah, what's next? Maybe your contribution, or use it in your campaigns. Thanks for today.
Thanks a lot, Peter. Nice examples there. I haven't seen that one from Indonesia earlier. I'll be adding points tomorrow when I take a walk around Portofino, just to let you know. Do we have any questions in the room for Peter? Nothing around? Sure? You're in your new office, aren't you?
Yep.
Nice place. Nice place. Okay, we have no questions from the audience here. Antonio, anything to add?
No, I was saying we can move on the next presentation.
We get going. Thank you, Peter. Be in touch in a little while. Thanks.
Thanks again, Peter. And we move on the next presentation, that is from Susanna. That is going to present, an application similar. Somehow it's very similar in the concept, but the application is for a different purpose. So it's about identifying algae species in support of the Environmental Protection Agency. Adesso puoi prendere avanti. So, the floor is yours.
Thank you very much and good afternoon. I present you this project that is already finished, but we would like to continue to use the system developed and use and improve it in another application in the next project that is Nautilus, already mentioned before. Alga warning is a smart solution for in situ monitoring of the toxigenic microalgae. Microalgae are unicellular photosynthetic organisms belong to the phytoplankton. Phytoplankton is fundamental for our life because they produce about the 50% of the planet's oxygen. So it's fundamental for our life and the life of each organism. They have a lot of different morphologies. They belong to different families and species. They are different colored and many features. You can see some particular picture of this, and they are very nice. Also, also that important. But sometimes, and some species can be harmful. Harmful because they grow without control, and then create impact on human and ecosystem health, and consequently also a socio-economic system. In the picture you can see very recent phenomena verified in June this year in the Michigan, and in the other picture you can see another phenomena on September or the last years. So they are present in fresh water and in marine water, so everywhere. This phenomena is a worldwide phenomena. So there is a very important database that collects each event in the world, and till now they count more than 19,500 events. About the 50% include seafood biotoxin, and about the other 50% include phytoplankton counts. So the consequent water discoloration and the problem of fisheries. A specific situation in Italy is due to a bloom about Ostreopsis ovata that produces high toxic compound and that induce eye and skin irritation, headache and fever. Another species that grow a lot in Italy is Prorocentrum lima, that produce another kind of toxins that produce the famous diarrheal syndrome, and another species, the Culia monotis, that fortunately in Italy don't induce any toxicity for human. Obviously, this phenomena is very important, so exist some guidelines for recreational water quality monitoring. These are protocol quite the same in each state, but and they consist in periodically sampling, monitoring in the lab under the microscope, and then the findings are reported and published. But this procedure has a lot of limits because, first of all, it is costly and requires labor-intensive laboratory analysis. In fact, the alert is reported after about 38 to 72 hours after sample. And consequently, number of samples is limited in terms of time and in terms of space. So, Alga Warning want to pass over these limits, and in fact, it is a portable system for in-situ acquisition, that means directly on the beach, of the microscopic images of the water sample. We integrate two commercial devices, a dipole micro lens and a sample chamber specific for phytoplankton. Integrate all this part, all this hardware part with a specific application. You can take every kind of a report in which we can add not only the image taken by the camera of the smartphone, but only you can add other information that you want to supplement and count the cell in the single image simply by tapping on the picture. In this way, by using the special sample chamber, you can say also the concentration of the cells in the volume. The other important part of the alga warning system is the web application, in which the reports are automatically integrated, and you can see real time each report that each smartphone collected during the field campaign. In which way you can see in the map each report, but also in each specific report and in each specific details. This particular web application is important also because you can supplement it with the further data, other data important, such as, for example, other data that we collect by using this special device, a fluorimetric device, that is able to understand automatically and recognize automatically the different orders and families of microalgae contained in the water sample. So you can add in the same time in the screening taken in the beach and the screening taken in the lab. Otherwise, you can add also a toxicity assessment of the sample. So you can integrate not only the quality and quantitative data, but also the information about the real toxicity of the specific mixture of algae present in your sample. Next steps of our project is continue to use and improve the instrument and organize a citizen science campaign in the Nautilus project to create a strong data set that will be integrated in the Nautilus data infrastructure. For further analysis, for example, image processing, so you can in the future recognize directly from the image the species of the microalgae. And then another important thing is to discovering new emerging alga species that are not evaluating in the periodic monitoring of the environmental agency. And that is all.
Thank you. Thanks a lot for that presentation. So again, any questions in the room? Yes. I'll come along with the microphone.
Thank you. Hi. So my question is about in situ measurements. If there is any parameter that you can measure around the area where you suspect harmful alga bloom, that you can already have a pre-assessment in situ? So, I don't know, like oxygen levels or colors or things like that.
Till now, you can take in situ, you can take also the image, and an expert people can understand if they are toxic or not, or recognize the species. You can take a sample in the species, in the site of interest, and see only the sample in situ. In other situation, you can decide to to take the sample and then to go into the lab and confirm what do you see. If there is the question.
Yeah, I was wondering whether there is a way to pre-assess before, like taking the physical sample or the picture, like if there is an environmental condition that can indicate that in that case there is algal bloom. Like, you know, from satellite image you can see already the patch of color, and that's a good indication normally.
Yes, of course there are physical characteristics, maybe the color of the water, the mucus that you can see in the site, also atmospheric situations such as no wind, no current, in which algae want to grow a lot. So you can decide, obviously, the best site to put your sample. Yeah, of course, yeah.
Okay, thank you.
I would like to know just, well, a couple of things. One is who are the experts that then look at the images taken by the citizens? There is like a group of scientists, or who is then judging the images and looking at?
All people that want to collaborate can take a picture because it's very simple to use.
So there will be like a community where people can go, like a place where people can go and contribute?
Yes.
Okay. And what is the price of the system for citizen science project, roughly?
About 200 euros all together.
And people have to concentrate the water, or they just put it and look at it?
It depends on the site, when, as mentioned. If there is a lot of color, a lot of mucus, a particular situation, you can put it directly, because there are a lot of cells. But otherwise, it's better to concentrate by a filter and then put in the sample chamber.
Okay, thank you.
Good questions. Everyone's pretty amazing in this room. It's Friday afternoon. We have one presentation left, okay? Before that, because we made a picture in the morning, but that was more for the morning people around. If we can just take a picture now of the group that's here, so we also have an afternoon picture, that would be really, really good. And then we just have one presentation left. Is that okay? So if we can get everyone up here, up to the stage, that would be fantastic. Thanks.
Afternoon speakers, please.
Yep. Come up on the stage. No, but he's gonna, we know what we're gonna do with that, right?
Everyone, just get up there. Why not? It was also the one in the morning.
It's a good way to prove that you were here all day. Why not? We're ready? Okay, so final presentation of the day is Antonio. Come along. It's the final one, but now everyone has energy back because now they've been moving around a bit, so the blood is back up in the brain, okay? So, so over to you.
Okay. Thank you so much. Okay, good afternoon, everybody. This is the final presentation. Good enough, the weather outside is not so good, so you can still stay
inside and listening to this presentation. What I'm going to present very briefly is the current status of a EU project whose name is iChange, funded under the big umbrella of the Horizon 2020 Green Deal calls, which is devoted to get as much as possible citizens involved into the climate change topic. Okay. The project is a project lasting quite few time, 42 months. We are now really in the middle of the story. The project will finish in April 2025. It is a project built around a quite large consortium of 17 different institutions in Europe, in Middle East, in Israel, and also in Sub-Saharan Africa, in Burkina Faso. And the project has three main actions in mind. One is to raise awareness of people around the climate change topic, but not just purely let's say, a frontal explanation of what climate change is, but we want to engage, and we are doing so, citizens in direct collection of environmental data that in one way or the other may help in understanding climate change processes. And also, possibly, hopefully, and this will be certainly the most complex part of the story, to get people convinced about possible behavioral change in order to reduce their own carbon footprint. So we want to listen to people, get together understanding what it is climate change, how it is taking place, get them involved in monitoring of different processes through a set of 8 different living labs spread around Europe, Africa, and Middle East, consolidate understanding, and as I said, the most tough part, to try to change behaviors. Genoa is one of the living labs involved. We are mostly focused on extreme events, and this morning you had a kind of example, just a few tens of kilometers far apart in Bogliasco, we had 150 millimeters of rainfall in 3 hours. So it was a very extreme event. So in Genoa, we are focused on extreme weather events, the same in Barcelona. In Bologna, we work mostly on air quality and mobility topics. In Ouagadougou, we are dealing with waste management and water cycle management improvement, and so forth. As I said, in our living lab, we have basically decided to deal with extreme weather studies. This is an example that I will present later on. It has to do with a major hailstorm that took place last year in Chiavari and Sestri Levante. We are also starting to work on heat waves and urban heat island effects, and to some extent more in a teaching mode with students on air quality problems. Why we are mostly focusing on extreme events? Well, because all the Mediterranean coastline is deeply affected by different extreme events, starting from evergreen, like back-building mesoscale convective system that have been occurring along the Mediterranean coastline since a long time. And Genova was affected in the last a little bit more than a decade, in 2010, 2011, 2014, and 15 by those events highly localized. But we have also, beside those phenomena that I did present also a few days ago, which are characterized by an extreme localization, very short duration, few hours, and huge lighting activity, capable altogether to pour down up to 500, 600 millimeters in a few hours. We have also some kind of new entries. And among the new entries, there is, to some extent, this example that took place last year, not too many months ago in August, when a major derecho event developed in southern Spain, in nearby Balearic Island, moved across the western Mediterranean, and was capable to produce, this is in northern Tuscany, an hailstone big like 12 centimeters. This is an image of a building, Sestri Levante, which is not far from Portofino areas that we mentioned before, completely affected by hailstorm hitting the building walls. This event was strongly supported by very specific sea surface condition and atmospheric condition. Then what we are trying to do into the project in order to engage citizens? Well, we started to spread around a certain number of personal weather stations, a very standard one, but all those weather stations are in one way or the other located in school buildings, so that the students can get interested more directly in collecting data about temperature, pressure, relative humidity, wind, and so forth, and maybe love a little bit more mathematical application instead of classical studies. But we are also installing in the very same location simplified air quality sensor. Those sensors don't pretend to be state-of-the-art, but to give a sense of air quality measurements. And for example, a few days ago, we had some of those sensors measuring the biomass burning aerosol coming from North Canada, the big wildfire, crossing the Atlantic, arriving from north here. And we have a major increase in all those stations located in schools about this particular kind of aerosol. And we have also, this is probably the most interesting sensor, we have also sensors which are in some sense capable to be meteorological sensor in the move. Those are sensors that, the name is Meteo Tracker. You can install on your bike, you can install on your car, you can install on boats. One of the students in one of the primary school was proposing to install on his own cat and to use the cat as a sensor-like animal. I am not sure if the cat could be very happy about that, but we'll try in September, we'll see. But there are nowadays quite few groups using those sensors and collecting also now in real-time data. What those data can help to do? Well, classical weather stations like this one located not far from here in Valpolcevera area helped to collect for quite long time, 5 years, weather data in one of those valleys. And what we did in a very simple manner, but it was effective to attract the interest of people, was to compare the monthly average temperature in these premises versus the local climatological value. And what was apparent was that in the last 5 years, every month was by far higher in temperature than the climatological value. And beside that, we also discussed the fact that in the last 1 year and a half, all the central Liguria area was receiving much less rainfall than the actual expected climatological value. So people spoke a lot in the last 2 years about the big drought condition into the Po Valley. It is certainly a major problem, but also small creeks like the one in the Genoa area are experiencing drought condition with rainfall much lower than the expected value. Just to give you a number, last year in certain part of Liguria municipality, we had less than 500 millimeters of rainfall when the climatological value is 1,300. Then we did something maybe a little bit more fancy. We tried to understand more about this event, the derecho event. And so, just to give you an idea, this is what the event produced. I presented already on Tuesday this movie. This is the hailstone falling down in the Sestri Levante harbor. And those were hailstones big more or less in between 5 to 10 centimeters. At a certain point, you are completely losing track about the boat's position, the sea component, atmospheric one. Because the downburst due to the collapse of the atmospheric structures, was entering into the coastal region. Good enough, nobody was affected, no death toll because of this event, probably also because it was early morning. This is another video, if it is working, where this person had at the beginning a nice new car, and after a few seconds, the car was not in very super good conditions. So what we tried to understand was to use the meteor tracker data measured by the boats bringing around the day before, which was a perfect sunny day, in between Santa Margherita Ligure and Rapallo and 10 to Portofino. We tried to collect temperature data, and also the day before was a very perfect day for supportive convection, very high temperature values, very high moisture conditions. And what it is also interesting to show, this is just another boat which is making the transport in between San Fruttuoso, Portofino, Santa Margherita, Rapallo. What it is interesting was that also those are Copernicus data, sea surface temperature data. Also the sea was very warm, above 28 degrees. So the conditions the day before were very supportive to trigger deep convection as it was happening. And this is just a simulation, you assimilating certain of those data into the WRF model. We studied also less impacting event. This is a Caligo episode. It is fog over the sea that sometimes is developing in front of the Genoa coastline. This is the location nearby the Genoa Aquarium, completely hidden by fog. And we had Navebus, which is a local bus moving people from Pegli in Genova City to the central city. And it is very interesting. At a certain point, the boat completely entered into the fog. The relative humidity was very high. This maybe is not, let's say, top-level science, but it is a very nice way to engage people, to get interested into the topic and to learn more things. And once more, this is the comparison between the sea surface temperature value that day from Copernicus and our track from the boat. So, all in all, we are showing that there is value in those data in order to get the people interested, and also listening to the other presentations before mine. I think that also the data collected, for example, from the boat nearby the Portofino Promontorio can be of our interest, and on the other hand, we can share our data for other applications, really into the spirit of putting data together. And one of the ideas that we are developing with Antonio is to use a national project, PNRR, to put all those data together for common usage from other groups. Thank you for your attention.
Thank you very much. That was an interesting one, and you bring in the Copernicus stuff there too. That's a cool presentation. Thank you. Do we have any questions here in the room for Antonio? No final questions, right? So what we will do, we'll let you go, we'll release you, but we do have a couple of videos that we're just going to put on the screen. If you want, we join us for a little bit of something to drink. We can keep a look at the videos. Antonio Novellino is not around. He wants to be here to thank everyone. He's not here. So we can give him maybe a couple of minutes and we can see if he shows up. I'm incredibly impressed with what everyone is doing in this room. There's been some suggestions during the day to create a kind of community science observing system to really bring all this together and really maximize the impact that we can have with what we are doing together in this room. And it's for sure something that I will be thinking of how we're going to try to form this in the future, because there's so much potential. It's very, very, very cool. It's pretty amazing. So join us for a drink. have a look at the videos. We can see if Antonio gets back in time. If not, Valeria, you've done an amazing job organizing everything around here. Together with Antonio and other colleagues from ETT, a big, big, big round of applause for you guys. For me, it's been pretty amazing. When I've been worried, wherever I've been, often up in Sweden, when I've been worried about things, I've been texting Antonio, what about this, what about this, what about this? He says, calm down. She knows what she's doing. So thanks a million, okay? Yeah. And enjoy what's going on out here. So we put some videos on. For those who want to stay around, join us for a drink down further down the room. Thanks.
Hello guys, how are you? Enjoying the ocean race. I'm Ivan Alonso, R&D Electronics Engineer in Aquatech Group, and today I'm going to present you our new passive broadband sound and click recorder, which it involves two of the sensors that we provide for the European project Nautilus. First of all, I would like to say some words about who we are. We are Aquatech Group, a small company founded in 1990 and based in Basingstoke in the very nice county of Hampshire, southern of UK. With more than 30 years of experience, we are creators of innovative instruments, services and solutions for measurement, monitoring and communication underwater. We provide solutions for all water environments, including offshore structures and pipelines, oceans, rivers and lakes. We have 3 dedicated brands currently active. On the left, you can see the sediment solved, which it covers all related with turbidity loggers and acoustic sediment profilers. In fact, our new active acoustic profiling sensor is another sensor that we are developing for Nautilus. On the right side, we cover all instruments related with the subsea integrity, such as leak detection, cathodic protection, etc. Finally, in the middle, we cover all instruments related to the marine bioacoustics, where we can find the topic of this presentation, which is the click and sound recorder, related with the marine soundscape monitoring. The main question is, what do we want to measure? What do we want to record? This is a very nice picture to get an idea about where the underwater sounds are coming from. We have got different sources, earthquakes, weather, like for example, storms, heavy rains.
So, dear all, I want just to thank you all for coming, enjoying, making the event very nice and complete. So I would like to give you one last big applause. Picture. And above all, we need to thank all these guys, and a special thank to Valeria, that you know.
Bene, bravi. Adesso un bicchiere per... quindi alla dritta devo scendere. Se no se c'è spazio.
Which it involves two of the sensors that we provide for the European project Nautilus. First of all, I would like to say some words about who we are. We are Aquatech Group, a small company founded in 1990 and based in Basingstoke in the very nice county of Hampshire, southern of UK. With more than 30 years of experience, we are creators of innovative instruments, services, and solutions for measurement, monitoring, and communication underwater. We provide solutions for all water environments, including offshore structures and pipelines, oceans, rivers, and lakes. We have 3 dedicated brands currently active. On the left, you can see the sediment solved, which it covers all related with turbidity loggers and acoustic sediment profilers. In fact, our new active acoustic profiling sensor is another sensor that we are developing for Nautilus. On the right side, we cover all instruments related with the subsea integrity, such as leak detection, cathodic protection, etc. Finally, in the middle, we cover all instruments related to the marine bioacoustics, where we can find the topic of this presentation, which is the click and sound recorder, related with the marine soundscape monitoring. The main question is, what do we want to measure? What do we want to record? This is a very nice picture to get an idea about where the underwater sounds are coming from. We have got different sources, earthquakes, weather, like for example storms, heavy rains, different animals, and also some human sources like ships or wind farms. On the right picture, it is a very good view of where these underwater sounds are in terms of frequency. In very low frequency, we have got some seismic events, undersea earthquakes, submarines, and in high frequency, we have got some interesting sounds around 100 kHz, like the clicks. However, what is a click? Basically, clicks are pulses of high frequency used by dolphins or porpoises to sense their surroundings through echolocation. In the first picture on your left, you can see how the dolphin locates its target, in this case a fish, using the system. In the picture on your right, you can see a train of these clicks and also a zoom in one of them. Below, you can find the measure method that we use to determine the length and the level of these clicks. We set a threshold voltage in order to check where are the start and the stop of the click and comparing at the same time with its envelope. Now, let's talk a little bit more about the new device. As I mentioned before, we have to develop some sensors for Nautilus. Two of these sensors are the sound recorder, which is something new for Aquatech, and a click recorder, which it will be a new version of a previous product. These two devices will be focused on different activities, such as acoustic observations for detection and mapping of marine mammals, detection and location of seismic events, monitoring of acoustic impact of human activities, etc. In light of recent distressing international news regarding lost submarines, it serves as a poignant reminder of the critical significances of these devices in listening to and analyzing the underwater sound. Being in a testing and demonstration stage of the device, we are able to change or improve different parts of it, but at the moment, these are the most interesting features. The device has a built-in house hydrophone designed by Aquatech. It is able to record sound from very low frequency, 5 Hz, to 150 kHz, and click events at the most common echolocation frequencies. There are different configuration modes available in our PC software, being user able to set the device as a sound or click recorder, being two sensors built in the same instrument. It has other functional sensors like a 9-axis motion sensor module, temperature sensor, and some extra communications. It is a standalone device with its own rechargeable battery with a minimum autonomy of 2 weeks. That's all. Thank you very much, guys, for attending the event. I hope you have a very great day at the Ocean Race. If you have any questions about the click and sound recorder or any Aquatech instrument, please do not hesitate to contact me by email. Once again, thank you very much, guys. Take care. Bye.
Good morning, everyone. My name is Sergio Stagno. I am the coordinator of the MEDSI-POD project, and in this presentation, for the next 5 minutes, I promise, I'm going to walk you through the Mediterranean Sea People Observatory Data, MEDSI-POD project, and by the end of this presentation, I hope you will be a little more interested in our project. So, let's get started. What is MEDSI-POD? In short, it is a research and development pilot project based on scientifically rigorous processes for collecting big data of temperature in coastal marine areas. And all of this will be done through the intense use of citizen science activities, which is one of the main goals of this project. Our project, MEDSI-POD, aims to process, display, and share the collected data not only with scientific community, but also with policymakers and civil society through an innovative and interactive data visualization system. Acquired data could be used to develop new conservation programs for coastal ecosystem, and last but not least, will serve to raise awareness among the population about the effects of climate change currently underway. There are 3 main goals we have decided to achieve in our project. Let's have a look. Firstly, create a dataset of temperature of the coastal areas of Sardinia. This dataset could constitute a benchmark for future measurements and analysis by the global scientific community. Our second goal is to generate an active awareness of the impact of climate change on marine ecosystems, and this has to be done specifically in public opinion, in citizens, and in political decision makers. Thirdly, popularize scientific research. It means making the research easily understandable and shareable to make it perceived as essential to the environmental, social, and economic well-being of all operators of the sea and citizens. How MEDSI-POD works. The temperature data will be acquired by use of commercial sensors. Needless to say, they will be periodically validated by comparing its data with those collected by the high-resolution multiparametric probes used by researchers of the National Research Council. The sensors will be distributed to different subjects who leave the sea as free divers, diving as sub-centers, underwater fishermen, snorkelers, local fishermen, and so on. These people will be the active protagonists of our citizen science activities and will obtain a dataset of temperature data collected all around the beautiful islands of San Pietro in southwest Sardinia. What are the expected results? Well, the dataset will be used as a benchmark for analyzing ongoing climate change and predict future climatic scenarios. MEDSI-POD is a pilot project aiming at creating the first dataset of coastal environmental data of Sardinia. Specifically, MEDSI-POD will create the first coastal thermal map of Sardinia. Data could be used by numerical models to define more accurate sea temperature forecasts in the coming decades in coastal areas. Further steps. Collect coastal environmental data from the other areas of the Mediterranean, and improve the acquisition system by including other environmental sensors, for example, dissolved oxygen and conductivity. In conclusion, let me say 2 words about our 3 main project teams. First of all, our scientific partner, the Institute for the Study of Anthropogenic Impacts and Environmental Sustainability in Marine Environment, part of the National Research Council. Then, the ICT partner, NetSol, specialized in software development and communication, to finish with Maraltro, which is in charge of the communication strategies. Thank you very much for your attention. Grazie. If you are interested, please send an email to info@medzipod.org. Good morning, everyone. My name is Sergio Stagno. I am the coordinator of the MEDSIPOD project, and in this presentation, for the next 5 minutes, I promise, I'm going to walk you through the Mediterranean Sea People Observatory Data, MEDSIPOD project, and by the end of this presentation, I hope you will be a little more interested in our project. So, let's get started. What is MEDSIPOD? In short, it is a research and development pilot project based on scientifically rigorous processes for collecting big data of temperature,